Hi everyone, this is Secure Coding for SSL SOAP and REST, and I'm Astha Singhal. So let's get started. First and foremost, this is the last day of Dreamforce. I'm pretty sure all of you know. Please don't make any buying decisions based on this presentation. All I'm trying to tell you is how to secure your APIs. Okay, a little bit about myself. I'm Astha Singhal, and I am a product security engineer here at Salesforce. So as a part of my job, what I do is I work with product teams at Salesforce to build secure applications for our customers from a design standpoint, from an implementation standpoint, for making sure that they understand the security bugs, for making sure that they understand the fixes for these issues, and then also working with them during the process to kind of do like more security training so that they can do more self-service for doing their own security testing for things, building that security knowledge into the teams so that they can integrate it better in their development lifecycle. So today we're going to talk about, mostly we're going to talk about API and transit security. The topics that we're going to touch upon is, what are the common pitfalls or what are the common mistakes you could make when you're building your own API? And then we're going to touch upon what are things you would take care of when you're integrating with other existing APIs, meaning for APIs that already exist, how would you build secure integrations? So first of all, API first, what does that mean? Everyone's like, okay, you don't want to limit your application to things that you've already built, right? You want other people to be able to do more cool things with it. So for example, at Salesforce here in the past few years, that has been a big push where Salesforce is trying to make APIs available for most of the functionality within Salesforce. So now what that does is it helps our partners and it helps even our customers who want to build, custom integrations in their own premise. They can do that. So with an API, what is an API? An API is how you define the behavior of an application, right? So okay, these are the operations it can perform. These are the inputs it's looking for, and then these are the outputs that it's going to give you back, and these are the data types that it expects for the different inputs and outputs, right? Now you expose these APIs like Salesforce does so that people can build custom integrations, and custom integrations means that there's going to be more functionality, and that's going to mean more people are going to want to use it. That means more people are going to make money. So everyone's happy. So what's important there? You want to make your app easier to integrate with because no one wants to go and screen scrape your application and then figure out, how to figure out the data they need, right? So you want broader usage, and that's why here at Salesforce we have APIs available for most of the functionality that you can do within the app. And one good thing is, as the person who's building the API, now it's not your problem to worry about the presentation layer, right? All you did was, okay, you need all your report data. You make this API call, and then I'm going to give you back this JSON blob, and then you figure out what you want to do with it. It's not my problem to have to figure out the presentation layer, right? So now we all see why there is a reason everyone wants to build API-centric applications, because that's how you can have a broader range of applications. Now, no presentation layer. Does that mean there is no security issues? Because in the previous sessions, we talked about so many things like, oh my God, cross-site scripting and, all these UI level issues. Does that mean that we don't have any security issues anymore? Well, we still do, but we don't have any presentation layer security issues. But there will be specific issues that are relating to either the API format that you're using, or there will be still issues like secure storage or doing your authentication and authorization correctly, business logic flaws, which is the most important of all. Those issues are still something that would exist when you're building APIs, right? So let's talk about two of the most common API formats that we use today. So the first one is SOAP. SOAP is Simple Object Access Protocol. What that means is you are exchanging information with the web server in a structured format, and the web server has specified the format, how it's expecting the input, and you're getting back the output in that same format. So usually it uses the XML message format, and it relies on any transmission protocol that you want to, right? So and most commonly used is obviously HTTP. So SOAP's going to define how you're doing the transfer, and HTTP is how you're going to transfer the messages back and forth. So here, the example that you see is I'm going to example.org, and then I'm doing a post, and then this is my whole SOAP body. This is where I'm specifying, okay, I'm trying to get the stock price, and I'm trying to get the stock price for IBM, and this is the endpoint I'm hitting. And then the SOAP endpoint gives me back the response with a 200 OK, that, okay, this is what you're looking for, and this is the format that I was expecting the request in, and it all looks good, so here's your response. Oh, one more thing I forgot to mention is during the session, if you have any questions, you can post the questions on the chatter feed of the session, so in your Dreamforce app. So if you do that, then we have people in the audience from the product security team who will be answering your questions. All right, sorry about that. Okay. So that seems like a lot of work, right? That means that, okay, I have to figure out the whole format of the post message that I'm going to send, and then everything has to be syntactically correct. That sounds like a lot of work. So there's also REST, right? What is REST? REST is you're specifying the entities by the URL path elements. What does that mean is you're interacting with a web-based system by just giving it a URL. So here what you did was you just said that, okay, I want to go to example.org, and I'm going to hit the in-stock endpoint, and then I'm going to get the stock price for IBM, right? So this seems way simpler because I don't have to worry about building that whole envelope, right? So now, based on, these are the two most commonly used API formats, and then based on what you're doing with the data that's coming to you, there would be different types of issues. One thing that's very, very important that, you know, is important across the board, irrespective of what format you're using, is doing input validation. We talked about input validation a lot in all of our other sessions, meaning when we were talking about building secure external app integrations with Salesforce, we said that, okay, make sure that you never trust your user blindly because, well, that's the fastest way to get hacked because you have a benign user, and at the same time, you will have malicious users trying to use your application, right? And then in this case, where you are expecting the input in a certain format from the user, what's important is making sure that the user did provide you the input in that expected format. Meaning, okay, so for example, if you're building the SOAP envelope, right? I don't think you expect the user to ever have being able to create new SOAP elements as a part of the input itself, right? Because you're not expecting them to build the format in their input. You're expecting them to follow the format that you provided and then just enter the data there. So first and foremost, make sure that your user input adheres to the expected format. Now, one good way of limiting inputs is using whitelists. Using whitelists, you can define a set of good inputs, and then you can make sure you can test the user input against those set of good inputs, and then only allow that. The one thing to note here, which I've mentioned previously in other sessions, is make sure that you're doing a whitelist filtering and not a blacklist filtering. What that means is don't say that, okay, I don't want you to enter angle brackets because then you will be able to create a new node. No, make sure that, okay, I only expect you to enter alphanumeric characters, so if I see anything other than alphanumeric characters, I'm going to reject the input. So make sure that you're using whitelist filtering because anywhere there is a blacklist filter, there's always a way to get around it. And then once you, when you talk about SOAP, then you talk about, well, what do I do once I get the user input, right? So make sure that when you are parsing that XML in the SOAP request, make sure that you are using a, an already written by a trusted entity, a trusted secure parser for parsing your XML. Because if you go around building your own parsers, what's going to happen is you're going to run into a lot of injection vulnerabilities, which all these parsers have done all the work of figuring out how to not be vulnerable to, right? So making sure that you're using a pre-tested secure XML parser instead of trying to ever build your own. Now, one more thing is content types, right? when you're getting an HTTP request message from a user, you should make sure that the request content actually matches the specified content type header. So, because it's going to provide you a content type header, right? If you're not expecting a certain type of content type in your input, just reject the request right away, because nothing can stop the user from sending you unexpected content types, right? So if they're sending you a content type header which you don't expect, or if the actual content doesn't match the content type header, make sure that you reject the request. And when you're setting the response content type, make sure that you're doing that based on the response type that you're sending, and then not based on the request type that you got in the request. What I mean by that is the user supplied content type in the request should never be assumed to be, to infer the content type for the response. The server itself should decide based on what it is expecting to send back, what response content type to send back. And then one more thing is, we all know that there are browsers out there that try to be too helpful a lot of times, where if it can't figure out what the content type is, sometimes it might try to do MIME sniffing, which is it might try to figure out what the content type should be. So make sure that you're setting the X content type options no sniff. What that means is, in older browsers that might try to interpret, for example, you're just trying to send back a JSON response and you don't want it to execute in the browser at all, right? If someone's sending that to the browser, then you want to make sure that your browser never tries to interpret it as executable content. You want to make sure that you set the content type to no sniff. So this is things that you would take care of in terms of input validation, when interacting with user input directly, right? And then input validation also becomes really important in REST APIs as well, because you don't want a user to use the URL path to get to do like directory traversal on your directory, right? Because you want to make sure that they are limited to the action that you are letting them perform. You want to make sure that they can't give you, they can't try to access parts of your directory that you don't want them to access to. Now, now you figured out that how you're going to handle user input. Let's talk about authentication. Now, for APIs, that becomes a little bit more tricky because there is no UI tied to it, right? So there's not a username password box where the user can be like, okay, here's my username password, give me back a session ID, and then I'm going to use that session ID for the rest of the time. You can't do that. So you should make sure that based on the API you're using, how is the API expecting you to provide the authentication information, right? So if the API endpoint's like, okay, well, I am never gonna accept any authentication information in a cookie because really I'm doing a lot of state changing operations and I would like a custom header. So make sure that you understand what the requirement for the API endpoint that you're trying to hit is for authentication, and then make sure that you're building secure implementation based on that requirement. What that means is, let's talk about a few ways in which you can do this, right? So first and foremost, custom headers. What does that mean? Custom headers means that before I'm making that AJAX call out, so I built an application where I am doing really cool graphs of everyone's opportunity data on Salesforce, right? So at the time when I'm doing that AJAX call out, what I'm going to do is I'm going to set the authorization, set a custom header on my request before that request goes out. And then that custom header is something that a browser doesn't send automatically. That means that it requires me to explicitly go and add that. So I'm going to go and add that custom header. And based on that, the first thing that the Salesforce API endpoint is going to do is, OK, do I see an authorization header? Oh, yes, I do. Let me verify the value of the authorization header, make sure that the operation you're trying to perform is valid, and make sure that the session information or the access token that you've provided me is actually valid, right? So the first one is custom header. Seems pretty secure to me because that is something that someone has to deliberately do, right? Second is session cookies. Sometimes people can, either there can be endpoints where they could be just using, okay, what I'm going to do is I'm just going to look at your cookie header and I'm going to see what you have in there, and then based on that, I'm going to decide if I want to give you access or not. Okay, that seems a little bit dicey, and we'll talk about why that might be a problem. Third one is API keys. This is a very commonly used thing that we see in a lot of Salesforce integrations, meaning if you have an external API that you're hitting, what you do is you store that API key somewhere in Salesforce, and then every time when you're making that call out from Apex to that API endpoint to get the information you need, you just kind of go and find that API key, and then you stick it into the request wherever it's expected, and then the API endpoint is going to be like, all right, this looks good. You should have access. I'm going to give you access. And then the fourth is you somehow just get the user's username and password as a part of each API request. So something like basic authentication, right? That sounds, well, we'll talk about that more. OK, so first of all, please do not use basic auth. What you're doing is, when you're using basic auth, you're sending your long-term secret, which is your user's username and password, in each and every request. What that means is if ever they're sitting on an unencrypted channel, or if that request ever ends up in like a log somewhere, or that's going to compromise their long-term secret. And it's not even like, it's not giving you any encryption guarantees or secrecy guarantees by itself. All you're doing is base64 encoding the username and password and sending it along each and every time, right? So that's just definitely not a good security practice, because all of us again are like cringing when I'm talking about it. So make sure that you are establishing a short-term secret from that long-term secret, and then using that as your authentication credential. Because what's going to happen is if it's a short-term secret, and in the worst case, if 5 months later it gets compromised, well, it's not valid anymore, so it's not useful, right? So that's still a problem, but that's a more manageable problem than compromising your username and password, right? So the second thing is, if you're doing session-based authentication, I would recommend that you do session-based authentication using custom headers, because if you're using the cookie header, that means that a cookie header is something that your browser is going to send every time you send a request, right? And we're going to talk about why that's a problem. But for right now, take my word for it, and use custom auth headers for sending session token values. Now, when you're using API keys for authentication, one big thing that I would recommend is make sure that you're not sending your API keys as a part of the URL. Because URLs may be getting logged in proxy servers, or if you're using third-party tracking sites. So for example, if I have Google Analytics on my site, right? What that means is, that's a good thing. I'm going to get all kinds of tracking data of how are people using my application. But what's going to happen is when that request is going to go out to google.com, the page that was loaded, the referrer of the request that's going to google.com is going to have my API key in it, because that's just something that browsers do, or that's just behavior where if you're going to a third-party website from a certain page, your current URL is going to get leaked in the referrer. So never having any sensitive information in the referrer header or in URLs in general is best practice. So even if you're using API keys, make sure that you're posting them as a part of the request and not in the URL itself. And now, you could even be just using OAuth tokens via another provider, right? What that means is instead of figuring out how to do this myself, I was like, you know what? I'm just going to use OpenID, or I'm just going to use Salesforce Identity Provider. What that means is I'm going to trust Salesforce to give me the identity of who you are, right? So in that case, you could be trying to do just that, or you could be trying to do, OK, well, I need access to your Salesforce data as well, so let me get an OAuth token from Salesforce, and then I'm going to use that OAuth token as a part of my API requests to make requests to Salesforce to get your data, right? Now, in that case, one thing to understand is make sure that the OAuth tokens that you're getting are least privilege. What that means is if you only need access to basic information for someone, please only request that. Because what's going to happen is having overloaded permissions on an access token is equivalent to having the user's actual credentials, right? Because if you don't need that information, it doesn't make sense. So it's kind of like saying that, oh, I got a Candle app on my iPhone, and it needs my location and access to my photos and access to my contacts. Why does it need that? It doesn't, right? So making sure that you're following the privilege of least principle whenever you're generating OAuth tokens for your implementation, if you're relying on someone else to give you that authentication and authorization information. So now, when you're calling the APIs from the UI directly, make sure that you generate an access token instead of using the session cookie directly. There are a few reasons for that. First one, a lot of times it might be the case that the session cookie has HTTP only set on it. What that means is they don't want JavaScript to directly access their cookie. So when you're going to do document.cookie, you're going to get nothing back. So making sure that, and then that's in general good practice. So if someone wants to be able to do that, so for example, in their Salesforce org, if someone said that, okay, I want the HTTP only attribute set on my cookie, they shouldn't have to go and disable that security requirement just because they want to use your app, right? You want the user to give the security settings they want. So you want to make sure that instead of using the session cookie directly, you're generating a proper access token for it and then using that access token. And in general, generating a custom API token will give you better control in terms of being able to define the access scope and maintaining least privilege, which we already talked about. And you don't want the user to disable security settings that they don't want to, right? So we said that we want to send authorization information in a custom header and use the cookie header for that, right? Let's talk a little bit more about why that's the case. Now, whenever browsers are really helpful, right? I love Chrome, and I love I love the fact that it knows that, okay, I went and logged HTTP stateless. So when I went and logged into Salesforce.com, my browser somehow makes sure that for all subsequent requests, Salesforce knows who I am until I log out, right? Or until my session expires. It doesn't require me to type in my username and password with every request, right? That would suck. So what happens is whenever the first time I go to Salesforce.com, Salesforce.com says, okay, your username and password looks good. Here's your session cookie. Let me set it in the cookie header. And after that, my browser is going to be like, oh, you're trying to go to Salesforce.com. You must need this cookie. So let me attach it. So what happens is every time a request is going to be made to Salesforce.com from your browser is going to think that Asta might need these cookies. Let me attach them, right? Now, the one pitfall there is cookies will be sent by your browser for cross-domain requests as well, right? That means that if I am on attacker.com, and then if attacker.com makes a request to Salesforce.com, my browser is going to think, oh, Asta's browser is trying to go to Salesforce.com. I must attach her cookies. So now what that can lead to is, in this case, I'm on attacker.com, and there is an image source on the page that's trying to hit some servlet on Salesforce.com and trying to do something on Salesforce.com, right? So my browser is going to be like, oh, you're going to Salesforce.com. Here's your cookies. And Salesforce is going to be like, oh, request to hit this servlet, and I see valid cookies. Let me perform this operation. So what ended up happening was you, as a legitimate user, made an operation on your instance without even realizing it. So you did a state changing. It's a problem when that leads to something changing on your application, right? So for example, let me go and delete all contacts. What if the servlet was saying, delete all contacts in my Salesforce instance? All I did was I went to attacker.com, which is not very hard to get people to do. And then that led to deleting all of their contacts, right? So that kind of tells us why we can't rely on, just the cookie header, because my browser is always going to send the cookie header. Now, one way to prevent CSRF is including CSRF tokens in all state-changing operations, right? So CSRF tokens are first loaded as a part of the page, and then they're sent back whenever you're trying to submit that operation. And then if the CSRF token doesn't match, then Salesforce is like, no, this doesn't sound right. I'm not going to do this. But for APIs, there is no page load. So there is no CSRF token load. Now, what do I do? Does that mean I can't prevent, again, CSRF? Because APIs are always doing state-changing operations, right? A lot of times it could not be a get. It could just be a post of like, let me update this or let me delete this or all kinds of things. So the way you protect against CSRF for APIs is you use a custom header, which is an auth header for sending to the web server. So what's going to happen is your browser never attaches a custom header by itself because it doesn't know when and when not to do that, right? So what you would have to do is in your AJAX callout, you will specifically go and then you will set that custom header and then you're going to send out your request and Salesforce is going to be like, all right, I'm looking for an auth header. I see an auth header. This should be good to go. Let's process this request. One major thing to understand there is in case when there is no auth header present, please don't fall back on cookie. So if you're the person building the API, don't say that, oh, I don't see anything in auth header. Let me check if there's anything in cookie, because that defeats the whole purpose, right? Because your browser is going to send that, and you are going to have your user be vulnerable to CSRF if you fall back to cookie header. So if you're building the APIs and if you're doing custom headers, make sure that you never fall back to cookie, and then you make sure that you only look for the auth header and you reject the request if that's not present. Now, when you're doing authorization using OAuth, meaning Salesforce, I need Salesforce data for my app to work, and I want to get an OAuth token. What do I do now? First of all, make sure that the OAuth token that you're generating is least privilege. API access tokens should be generated for the desired scope. Now, once you have the OAuth token, what do you do with it? Now, on your end, it's equivalent to having the user's credential. So make sure that you're storing it securely on your external app. Follow the industry best practices for secure storage on whatever platform you're on, because it's equivalent to having the user's credential, and losing that would mean that everything that that token had access to, or everything that you had access to, is now compromised, and some random person has access to all that information. So follow industry best practices for secure storage, and make sure that you're not logging access tokens on both client and server side. OK, so that sounds good. OK, now we have figured out how to authenticate my user. We've figured out how do we make sure there's no CSRF, how do we authorize our user. Let's talk about HTTP methods. So this becomes more relevant when you talk about REST APIs, because you could be doing, OK, I want to be able to do a GET on a REST API. I want to be able to do a PUT. I want to be able to do a delete. But that's about it, right? Not all methods are valid for all endpoints. So make sure that you're whitelisting the methods that are allowed for each endpoint. What that means is if I'm trying to say, OK, well, I'm trying to do read report, right? I'm going to do get reports or delete reports. Now, those two things might be tied to different permissions. So make sure that you're defining authorization correctly for the different HTTP verbs. What that means is a user, I might be allowed to get a report, but I might not be allowed to delete it, right? So make sure that you're, first of all, whitelisting the HTTP methods, and second of all, making sure that you're authorizing each HTTP method correctly. Now, we talked about what are we supposed to do with our input. We talked about how do we authenticate. We talked about how do we securely authorize. We talked about how do we define our OAuth access tokens. Now, let's talk a little bit more about the transport layer, because we said that our APIs were only going to take care of how do you communicate, and it's going to rely on HTTP or some transmission protocol to do the transmission, right? So what are the security expectations of HTTP? Nothing really, right? What that means is anyone who's sitting on your network can eavesdrop on your traffic. Anyone who's sitting on your network can modify the traffic. And anyone who's sitting on the network can even divert the traffic. That's like the most basic thing you do when you proxy anything, right? When you have a web proxy running, that's basically what you're doing. You're sitting on their network, and you're eavesdropping and modifying and dropping and diverting the traffic, right? So that makes HTTP look really insecure, right? Because it's not giving you any security guarantees. So then comes an SSL. OK. So when a user is visiting a site over HTTP, they don't have any assurance of, first of all, who they're interacting with, and second of all, any guarantee of who can listen in on that conversation, right? So SSL makes both of those things happen. What that means is, first of all, it will let a server authenticate itself to the client, and vice versa if you do client-side authentication as well. What that means is when I try to go to https www.salesforce.com, some certification authority somewhere has, has certified the public key of Salesforce, and when Salesforce is going to give me that certificate, I'm going to be able to verify that, yes, that is validly Salesforce's certificate, and I'm trying to go to the correct website, right? So first of all, I'm now able to authenticate the server that I'm talking to, which is pretty important because I don't want to give my Salesforce credentials to attacker.com, right? Now, once you are able to verify the party you're talking to, then you can establish a mutual symmetric key, symmetric secret with Salesforce.com, which lets you encrypt all future communication that you're going to have with Salesforce. What that means is now you're guaranteeing confidentiality on that connection. So anyone who's sitting on the network, who's listening to from the first request when you went to Salesforce.com up until the end, they will not, all they would see is garbled. They will not be able to, even if they were sitting on that wire while you were doing the handshake, they will not be able to figure out the key that you established with Salesforce or what is the communication that's going on between you and Salesforce. Okay, well, that sounds pretty good. That means all problems solved, right? Well, that's not always the case. Why? Because people are really smart and they break cryptographic protocols. And that's why it's important to make sure that your web servers have up-to-date configurations, right? So you want to make sure, so this is something that happened 2 days ago, that someone found one in SSL version 3, and they were like, you know what, we actually don't have a solution for this. So all you can do is disable support. So the important thing to understand there is if you're going to support weaker ciphers and you're going to support older protocol versions, it's basically like not having that security at all, right? Because you're compromising the security guarantees of SSL. What that means is if you're supporting SSL version 2 and there's already a known exploit for version 2, then your attacker is going to be like, all right, they're using version 2. So what I'm going to do is I'm going to just go in and use that exploit, and then I'm going to be able to decrypt that communication, right? So making sure that you're keeping your servers up to date in terms of SSL configurations is very, very important. And we see this more often than we should, where on external apps, a lot of times, really weak ciphers or really weak old protocol versions are enabled. So how do you go about testing this? A quick test you can do is just go to sslabs.com, and you can just enter the endpoint of whatever you're trying to test, and then it's going to give you back a report with kind of like a grade rating based on all the currently known vulnerabilities in all the protocols, and it would be like, all right, you are supporting this certain cipher, you're supporting DES, and that means anyone can very easily record that communication and decrypt it offline, and that's not secure enough. So making sure that you're running SSL labs and checking that your server has up-to-date configurations is very important. Okay, I think I want to leave more time for Q&A, so I think I'm going to skip that. But basically, I was just going to go to SSL Labs and run it on SSL Labs, and we can see the report. But I would really encourage you guys to do that afterwards. Okay, let's talk a little bit more about Salesforce API, right? Now, whenever you're using any of the standard APIs on Salesforce, they're going to enforce CRUD and FLS for you, right? So you don't have to worry about, oh, if I try to get this field that this user doesn't have access to using the API, would Salesforce expect me to do the CRUD and FLS check? No. So if you're using any standard APIs, Salesforce is going to make sure that it enforces all those things, and you don't have to worry about CRUD and FLS. Now, when you're writing custom web services yourself within Apex, that means that Apex is running in system context. And in that case, you have to make sure that your custom web service is doing that enforcement, because Salesforce doesn't know what you're going to do writing code in Apex, right? It wants to give you the power of being able to write code however your use case is. So make sure that you're adding the CRUD FLS and sharing checks when you're building the custom web services. So for sharing, you'll make sure that you're using with sharing on your class. And then for CRUD and FLS, you're going to make sure that based on the operation you're trying to do, you're doing is accessible, is readable, is updatable, those checks on the input before returning it back to the user. And make sure that you enable API access for only profiles that necessarily need it, right? Because you want to make sure that you're giving API access to only users that you expect to have to use the API ever, right? So for example, in some cases, if you're writing, and if you're writing an access check, if you're writing something on-premise in your org, and if you're writing an access check on the Visualforce page level, so if you're writing any access check on the presentation layer, then API access to that org will bypass that check, right? Because now there's no presentation layer. So anything that you're limiting via, oh, you don't have access to this Visualforce page, so you should never be able to see this, that goes down the drain. Because now I can just directly query the API to get that information, right? So, and for cases where sharing is enforced via Apex and Visualforce, they would be unprotected when accessed via an API. So make sure that you understand who you're giving API access to and that user actually needs it. And some objects do not allow CRUD and FLS and sharing to be configured. So for example, custom settings and local namespaces, they do not allow being able to do CRUD, FLS, and sharing. So they would be accessible from the API. And obviously, API access will allow easy mass extraction of data, so be careful while you're providing API access. And then one more thing to note here for the Salesforce API is if you're using the Salesforce API, you also want to make sure that, okay, well, this is the IP range that my user lives in, and I want to make sure that that's only from where the requests are coming from, right? And then so if some attacker somewhere does get this access token from this third-party thing, they are not going to be able to make that request because you said that, okay, well, my IP range restriction says that you can't do that. All right, so let's summarize. Handle authentication credentials carefully, meaning in transit, in storage. Make sure that you're not using cookie header for authorization to prevent CSRF. Make sure you're using custom headers. Always perform proper input validation. User is never to be trusted. So always assume that your user is malicious and always make sure that the input looks like what you're expecting. And make sure that you're keeping your data secure in transit by using well-configured SSL endpoints. Just having SSL is not enough. Having well-configured SSL is what you need. All right. Thank you very much. I know that these were all the other secure coding talks that happened during the week. So please go and check out the Secure Cloud Dev Twitter handle. We are going to post links to all the slides for the sessions that have already happened. And a few announcements. The Force.com code scanner now supports Salesforce 1 and JavaScript, so please go and try it. And the alpha nominations for the Chimera web app scanner are open now, so make sure if you're a partner, then make sure that you can, if you want to try it out, then make sure you apply at that URL. And we're doing live security office hours in the partner zone all day, so please stop by if you have any questions.